In the last section of the day, we're going to talk about writing our own functions, which will then go into our own custom scripts. On your computer, please execute the commands as shown in the slide. This is also on page 140 in your book. If you have too many tabs open right now, feel free to close the prior tabs, like with the flow control keywords, to make space for these new ones. You can leave them all open if you want to, totally your choice. But if it gets difficult to see the names of the tabs, then you could delete the prior ones, or just close the prior ones. Don't forget tab completion. That'll fill in the name of the script for you. And also, even though it's shown capitalized, PowerShell is almost never case sensitive, so you just type in the first couple letters, hit tab, and it'll fill in the full name for you. So in this section, we're going to talk about creating our own custom functions. A function is just a block of code to which we've assigned an alias name. Having a block of code like this is very handy because, for example, you can pass in 0 or more input parameters. In other words, you can pass in arguments to your functions and make your functions do different things depending on the arguments that you pass in. Now, what is the output of your function? That is totally up to you. Your functions might output nothing whatsoever. They could run silently. Or they could output thousands of objects. We get to control this. The output of a function, by the way, is called the return of the function. Those two phrases mean the same thing. The output of a function or the return of the function, that means the same thing. Now, where do these functions go? Well, one place we saw earlier today, you can put your favorite functions into your profile script. So every time you launch PowerShell, your functions are created in memory, and you can now type in the names of your functions and run them. As an example, if you type in IP and hit enter, just the letters IP only by itself and hit enter, well, that's running a function that's in your profile script, and that function displays your current IP addresses. That's a very common thing to do, to have lots of functions that only have 1, 2, or 3 letters in the name of the function in your profile script. Think of these as like your own personal macros. So let's say that you ping a range of servers over and over again, and you don't want to type in ping and then the first IP address and the second IP address and so on over and over. Well, instead you could have like a little function named, how about just the letter P? And that one letter named function could execute all the ping commands for you. Now, another place you could have functions in your own scripts. For example, let's say that on a regular basis you are creating user accounts in Active Directory or resetting passwords on user accounts in Active Directory. So you have scripts for this. Well, in those scripts, you could have lots of functions for all the basic things that you do with users in AD, like creating users, setting their properties, resetting passwords, disabling them, moving them around, and so on. In fact, that's exactly what we're going to do in a couple of days. And finally, a third place where you could have functions, you could put them into modules. This is for larger, more complex solutions where you might have a team of developers all working together. So your job might be to create and maintain the module of all the functions for SQL Server. And your friend at the office, he or she writes all the functions for Exchange Server. And then there's a third module, let's say for SharePoint, and so on. So for a larger complex solution, we want a way to organize all of our functions. There might be hundreds of them, and you could place these all into separate modules. Now we could do things like assign version numbers to the modules, digitally sign them, centrally back them up, and so on. In general, as you're describing to yourself what your script needs to do, then each of the fingers, as you describe the tasks, each one of your fingers will correspond to one or more functions. So as you're thinking about it and you're brainstorming what you would like to do in your new script, you might say, well, first, right, and so you're touching your index finger, first I need to query an Exchange server, and then second, get a list of all of the mailboxes, and third, filter the mailboxes so that I only have a list of mailboxes that have more than 10 gig of email, and then fourth, I need to send a message to each of those people telling them to delete their spam. So as you're kind of brainstorming and planning what your script does, then each of your fingers, so to speak, as you're ticking off the different tasks or steps, very often each of those steps or subtasks will correspond to one or more functions. Functions then are like Lego blocks. We want reusable functions that we can use not only in today's script, but in tomorrow's scripts as well. Now, the good news is creating a function does not have to be complex. For example, the overall syntax here is the keyword function, followed by a name that you invent for your function, and then followed by a script block. You place your code inside the squirrely braces. As you can see in the slide, you could have a function named hi, and all it does is, well, say hi when you run the function. For example, I go back to PowerShell, and that's what I'm going to do. I do a dir of the function drive for all the functions named hi, and I don't have any. The function drive is like a RAM drive where all your functions live in memory. But now, if I type in the word function, I invent a name for my function, which is hi, and then I could put one or more commands inside squirrely braces. Now, if I do a dir listing of the function drive for any function named hi, now instead of an error message, it outputs an object representing that function. Once a function exists, I can now execute it by name. So on the first line here inside my command shell, I use the built-in keyword function. I invent a name or alias for my block of code, the script block, and then I put whatever commands I want inside the script block. But that by itself does not execute the function. It creates the function, but it does not execute it. To execute a function, you have to call it by name. And that's what I'm doing in the second line here. The name of the function is hi, so I just type it in, hit enter, and the associated block of code executes. So this is very similar to what we have in our profile script. We have a little function named IP, and when you run that, it shows your IP addresses. But what does that function look like? Again, I'll take a look at my profile script just like we did earlier today. In my profile script, I scroll down, and there's that little IP function. So this is a very common thing to do. When you look in the profile scripts of other PowerShell or network administrators, you might find that they have dozens of functions that have very short names. These are like aliases for commands that they execute over and over and over again. These are not really intended for public consumption. This is not like it's in GitHub. And we're not really sharing our profile scripts with other people. So it's perfectly fine to define your own custom functions that only have like a single letter or maybe only 2 or 3 letters in the name of the function. Here's one. I'm creating an array of possibilities, yes or no. And I'm piping that into getRandom. Whatever you pipe into getRandom will select one of the possibilities piped in at random and then output that. So there you go, you're not quite sure what to do. So you have a function called getMarried, and you can let PowerShell decide for you. Now these are just cute little one-liner functions, very common in people's profile scripts. Most of the functions in the rest of your scripts, though, will have multiple lines. And in this case, the syntax is you'll have the name of the function, an opening squirrely brace, one or maybe thousands of lines of code that are indented, and then a closing squirrely brace. That's a lot more common for longer functions. So you might look at this and say, well, again, what's the point? Why would I assign a name or an alias to a block of code? There's more. One nice thing about having functions is that you can define your own custom parameters, switches, and then pass in different arguments to these parameters. For example, at the bottom, I'm calling a function twice. It's named new network drive. Now the letter parameter takes a single argument, an argument which is a single character. It's the drive letter that you want to use. And then share path is the UNC path to the shared folder that you want to map a drive letter to. As you can see, you can call that function over and over again and then pass in different drive letters and different UNC paths. In other words, the function is reusable. Instead of hard coding the letter or the path into the function, I pass these in as arguments. Now I know that loosely speaking, we would call all these things after the name of the function. Loosely speaking, we would call all these things arguments. Technically, however, in PowerShell speak, dash letter is called a parameter, and m, that is the argument to the letter parameter. Same thing, dash share path, that's a parameter, and this UNC path after it, that's the argument to that parameter. So, how do you implement a function that takes parameters and arguments then? Well, here's something new. After the name of the function, you can optionally have a set of parentheses, and inside those parentheses, variables. Notice that the name of the variable is identical to the name of the parameter, except that parameters begin with a dash, and variables begin with a dollar sign. In fact, that answers a question. Why is it that letter and share path are legal or available parameters for this function? How can I use them? It's precisely because those are the names of the variables here inside the parentheses at the top. So if I were to name these variables at the very top, $foo and $bar, well then that would result in new parameters that I could use when I called the function -foo and -bar. In this case, of course, we're choosing parameter names that make sense, that remind us what type of arguments that we should pass in. So what's going on inside the body of the function then, inside the script block? Well, I passed in m as the argument to the letter parameter, and that argument now has gone inside the variable $letter. That's how you get data or arguments inside of the function. Same thing for the UNC path at the bottom. That argument, that UNC path, that's the argument to the share path parameter, and so that UNC path, that string, it goes into the share path variable. And notice, I can now use those variables inside the body of the function, and they keep the arguments that I passed in. So what's going on inside? Well, if the letter variable, this is called a parameter variable, is not like, well, anything colon. Well, if it's not like anything colon, that means there was no colon and a simple letter was passed in. So that's what I did, in fact. I passed in the letter m, not m colon. So because it did not match anything colon, what did it do? Well, we take that letter, the letter m, and we concatenate a colon to the end of it, and we put that right back into the letter variable. In other words, you can pass in as an argument either just the letter m, or you could pass in m colon. But one way or the other, it's going to be converted to m colon, either because that's how you passed in the argument, or because we're going to append a colon to the end. Now, why are we doing this? Because we have no choice. Because on the very next line, we're using a built-in commandlet, new SMB mapping. And when you use that built-in command for mapping a drive letter, the local path parameter takes an argument with a drive letter, but you have to have a colon at the end. So in other words, our little function here is fixing it up. It makes it so that we have a choice then, or we don't really have to know or care whether we pass in the drive letter by itself or the drive letter plus the colon. But because I'm using a built-in command for mapping a drive letter, and that command requires that the drive letter have a colon after it, that's why the function is doing it. And then of course, we pass in the remote path, which in this case I'm passing in as the share path. You might look at this and say, well, why not just run new SMB drive mapping directly? What do I need a function for? Well, this is what I could fit in the slide, right? So I've got a little function at the very top, and then I'm calling the function twice down at the bottom. In real life, though, your functions will typically be a lot longer, maybe dozens, maybe hundreds of lines. Something else to see again is that simply creating a function does not execute or call the function. It just creates it. If you do not call or execute the function down below, then that function does nothing. So imagine, you could have a script that was 10,000 lines long. It could be filled with hundreds of functions. But if you don't actually call any of those functions by name, none of those functions get executed. And you say, well, that's a crazy kind of script to have nothing but functions inside of it. It wouldn't be a script. It would be a module. That would be a script that would end with the .psm1 file name extension. And that would be the whole purpose of that script. It's like your own uncompiled DLL. It's a script which is nothing but a library of functions. You could then import that module onto your machine or into some other script, and then now you could call any of those functions from your module by name. The second main thing to see here is this. It's these parentheses after the name of the function. And then the variables that you use inside these parentheses here, that's what determines the available or legal parameters when you call the function down below. I know for the more advanced programmers who are taking the course, maybe for a third of the people taking the course, for you this is obvious. But trust me, for everyone else in the course, this is not obvious at all. It's quite weird, in fact. So you might have a mental image of how scripts run, like an old-fashioned batch script, where you run the script, you execute every single command from top to bottom just once, and then when you get to the bottom of the script, then you exit. But that's not what's going on here. At the top of this script, we're creating a function, but that does not execute it. It just simply creates it. And it's at the bottom of the script now where we run the function by name. So in a sense, the point of execution, the red bouncing ball, so to speak, as you're following along the flow of execution inside of a script, is bouncing up and down between the top of the script, the bottom, and then back up to the top of the script again. So for the people who are new to scripting and programming, that whole idea is actually very strange and weird. Now here's another new trick. At the bottom, I've got a function called testcshare. It has the computer parameter, and I'm passing an argument. It's the name of a remote machine, box 47. But notice that the second time I call the function, I've got another parameter, but hey, where's the argument? The list parameter, there is no argument after it. It's just kind of hanging there. Well, that list parameter is a special type of parameter. It's called a switch parameter. And here's something new. At the very top, here's our parentheses where we define the parameter variables for our function. And sure enough, there's the computer variable. That's why we have a computer parameter. And there's the list variable, and that's why we have the list parameter. But here's something new and weird. It's got the word switch inside square brackets in front of the variable. Now this can be confusing because just a few slides ago, we saw that there's a flow control keyword named switch. And these two things have nothing to do with each other whatsoever. This is not a flow control keyword. So when you put the word switch inside of square brackets in front of a variable, when you are creating a function, then that tells PowerShell that this is a special type of parameter called a switch parameter. And because that takes too long to say, switch parameter, these are just called switches. A switch is a parameter that takes no arguments. And that's why down below we just have dash list and there is no argument that follows it. Well, what's the point? Why would you have a parameter when you can't pass in an argument? It's because PowerShell will pass in an argument for you. Here's how it works. Any parameter variable declared to be a switch parameter will get a default argument of false. But if you actually include that switch at the command line when you run the function, then instead of putting false into that variable, PowerShell will put true into the variable instead. So why do they call it a switch? Well, it's like a light switch. It's off by default, but you can turn it on. So it's false by default, but PowerShell can put a value of true in there if you include the name of that switch at the command line when you run the function. Confusing, I know. Let's work through the example. So down at the bottom, I run the function testcshare. I pass in box 47 to the computer parameter. And that means box 47 goes into the computer variable. Now, we have a switch parameter, that automatically gets an argument of false, even though I did not specify that at the command line. It's PowerShell that gives it an argument of false. Now, inside the body of the function, I do whack whack, concatenate the computer name, box47, and then concatenate \C$. In other words, it's the UNC path to the C share on box47. That goes into the share path variable. On the next line, if list. Now remember, list is that switch parameter, and what is the argument, or what's the data inside the list variable? What's inside the list variable right now? It is false. So if false, do I execute the immediately following block of code? No, I don't. Because false is false. The test is false. And because that first block of code is not executed, PowerShell looks for the else keyword and it finds it. So PowerShell executes the second block. Now, what's going on in the second block of code? Remember that the share path variable has a string like whack whack box47 whack $C$. And I'm passing that in to a built-in command named test path. Well, what's that for? If I go back to PowerShell, we see that test path is built into PowerShell. You give it the path to something that exists and to which you have access, and it returns true. Now, on the other hand, if you give it the path to something that does not exist, like for example, I don't have a folder named not found, it doesn't exist at all, well, the test path in this case will return false. Now, what if the path is a shared folder on another machine? It's still okay. You can still test the path to a share on another computer. Now in this case, it returned true. I am able to access the $C$ share on the member, that's the other virtual machine running on my box, because I'm logged on as a domain admin, I'm a member of the administrators group at that target machine, and that means I have access to the $C$ share. Now, what about the X share? It doesn't even exist. So that's why this output's false. Same thing if I give it the name of a machine that does not exist, like for example, I do not have a computer named IIS. It doesn't exist at all. I couldn't even resolve it through DNS. So that also returns false. So in a sense, this is kind of like SMB ping. We're using the SMB protocol, server message block protocol, to test access to a shared folder on another machine. So instead of sending ICMP packets like normal ping, I'm using SMB. And with SMB, I'm testing DNS. I'm testing access to, let's say, port 445 of the target machine. And I'm also testing or confirming that I have the necessary permissions to access the shared folder. So with this one little test, I'm actually testing many things in one shot. It's like SMB ping. So that's what's going on right here. Test path, I give it the UNC path to that shared folder, and it's going to output true or false. But sometimes, though, I don't want to know just true or false can I access that share. I want to get a listing of the share. So notice, the second time I call the function, I include the list switch at the command line. Now, when you include the switch at the command line, when you run the function, PowerShell no longer puts false into that variable. It puts true into the variable. So let's see what happens the second time I call the function. The second time I call the function, box47, that goes into the computer variable just like normal. I include the list switch at the command line. So what does PowerShell put into the list variable? Yes, it puts in a value of true. Just as before, I construct that UNC path, whack whack box47, whack $C$, and I do if list. Now is list true or false? It's true. That means I execute the immediately following block of code. So instead of using test path, I do a dir listing of that shared folder. Now, if I can't resolve the name or I don't have the necessary permissions, I will get an error message. But on the other hand, if it works, I don't get an error message, and I get a normal listing of the contents of the share. Why would I do that? Well, maybe sometimes I want to know, is that shared folder on a Windows box, in which case I would see folders like program files and Windows and so on, or is that a Samba shared folder server, in which case I would probably not see those folders, I would see other folders. The main thing to see here is the role of the word switch inside square brackets, how that has nothing to do with the switch flow control keyword that we saw a few slides ago, and how it's PowerShell that's putting an argument inside that variable. It defaults to false, but if you include that switch at the command line, well then PowerShell will put a value of true into that variable. How would I use this in real life? Imagine that you have a function that has 20 switches. All 20 switches are set to false by default. But when you run the function, you get to choose exactly which combination of switches to add at the command line, and then the associated variable then would get a value of true. So instead of just having one light switch, you could have a function that has 20 light switches that are all turned off by default, but when you call the function, you get to choose which switches to turn on. In other words, which switches to include at the command line. If you use the switch keyword, and it's PowerShell that assigns a default argument to a variable, how can we define our own custom defaults? For example, we've got a function here called remove network drive. Now, if I pass in a drive letter, then that is the drive which is unmapped or removed. Now, on the other hand, what if I call the function and I don't include a drive letter at all? What's going to be removed in that case? Well, let's take a look at it. Well, first I go up to the function, and after the function I look for, hey, where'd my parentheses go? Remember on the prior slide, right after the name of the function comes a set of parentheses, and that's where your parameter variables are stored. Well, there is another way of doing it. Notice that I've moved those parentheses inside the body of the function. When you do this, you have to put the word param in front of the parentheses so that PowerShell knows why it's there. So these are the parentheses that originally would have come immediately after the name of the function, but now instead they're inside the function. So you have to use the param keyword for that. And notice, we have a parameter named letter, and it has a default argument of a string. That string is just a single star. So this is how you can define your own custom default arguments. So what that means is down below, when I run the function and I pass in my own argument, like for example the letter Q, well Q is what goes into the letter variable. But if I run the function and I do not specify an argument, well then the letter variable keeps the default as defined inside the function. In other words, a string with just a single character, the character star. If you had multiple parameters and you wanted to have default arguments for every single one of them, then you just do comma, and for example, I could define default arguments like this. So it's just a comma, the next parameter, equal sign, and then whatever you want the default argument to be for that parameter. In this example, this little function only has one parameter, but you could have, dozens. So what's going on inside the function? Well, if the letter variable is not like star colon, then just as we did before, we take the current argument, we append a colon to the end of it, and then we update the letter variable. So one way or the other, you either pass in the argument with a colon, or a colon will be added for you. Now, we're using a built-in command, get SMB mapping, then the argument to the letter parameter. Star colon means return them all. Whereas if I pass in just the letter Q, then the argument that will be passed in will be Q colon. And it only outputs that one map drive letter. The map drive letter using drive letter Q. So in either case, notice that the output of that command is either 0, 1, or many, drive letter mapping objects. Now, down below, we have remove SMB mapping. Force means get rid of that drive letter mapping and don't prompt me to confirm. I'm using this in a function, maybe for a standalone or hands-free script or something. So in that case, I don't want it to ask me or to confirm whether or not I want to get rid of it. I just want to get rid of it with none of the confirmations. Now, what about for update profile? The question is this a permanent drive mapping? So if I update my profile, that means I'm getting rid of this drive letter mapping. Let's say for drive letter Q, I log off and I log back on again, and drive letter Q does not come back. Whereas if I did not include that switch update profile, that would just temporarily unmap the drive letter. So that means when I logged off and logged back on again, since mapping drive letter Q is a part of my local profile, it would come back. So in this case, I'm really getting rid of that drive letter mapping. It's not persistent anymore. Now there's another reason we have to know about that param keyword. In all the examples so far, we've been looking at functions. But you can also run scripts and pass in arguments to scripts. So here's an example. I'm going to go back to my virtual machine, example subdirectory, and we're going to open up a script named PowerPing. This is also what's in your slide. So here's the entire script. It's only 3 lines long, if you exclude the comments and the blank lines. And I can run that script. I type in ./PowerPing PS1, and watch this. I do space dash, and notice, simply typing in the name of the script caused PowerShell to secretly read the script in the background. PowerShell found the line that said param and extracted this information. And that's how we get command line tab completion and IntelliSense even for our own custom scripts. That's how it knows that dash computer is an available parameter. So now I could pass in an argument. Let's say like quad ones, 1.1.1.1, quad ones. So what's going to happen if I were to execute this command as shown on the screen? What would happen? Well, there's a parser in PowerShell that says, hey, you are passing in an argument to the computer parameter. That argument then goes inside the script and goes inside the variable of the exact same name. If you're going to have parameters and pass in arguments to your scripts, the first executable line inside your script has to be the param line. The word param followed by parentheses and then whatever parameters that you want. So in this case, quad ones, that string, is going to go into the computer variable and replace the default argument. Now, by contrast, what if I don't pass in any argument at all? I just run the script as is. Well, in this case, the computer parameter variable, it had a default argument of localhost, and it kept that default argument. And as you can see down below, I'm pinging myself localhost using IP version 6. But on the other hand, what if I run that script and I do pass in my real IP address? Notice that I'm not pinging localhost anymore, I'm pinging the IP address that I passed in as an argument. So if you do pass in an argument for a parameter, it's going to overwrite whatever is there. But if you don't pass in that argument, you'll just keep the default argument. Now, what's going on in line 11? I create a function named pingWrapper. Does creating a function automatically execute that function? No, it does not. You could have a script thousands of lines long. Most of those lines are taken up by, let's say, dozens or hundreds of functions. But if you don't call a function by name, it doesn't do anything. It just takes up space inside the script. So in this case, I'm creating a function named pingWrapper, but I've not yet executed it. What's going on in line 13? Now I run that function by name. But that function is not in my profile, is not in an external module, It's not built into PowerShell, it's, well, right above me inside the script. So it's very common then that when you look at other people's scripts, you'll have comments at the very top, the param line, 0, 1, or many functions in the middle, and then it's at the bottom of the script that the functions are called by name. Now, the challenge here then is to follow in your head the flow of execution. And it all starts with me typing in this command inside the command shell. I'll give you a hint, we've already talked about it. 10111, that's the argument to the computer parameter. So that means 10111 goes into the variable named $computer. And then, as we just spoke about, on line 11, I'm creating a function named ping wrapper, but it doesn't run the function. But what happens when we get to line 13 here? PowerShell executes the function ping wrapper. It takes the contents of the $computer variable, which is 10111, and passes that in as an argument to the IP parameter. But that's the IP parameter to the function. So what's inside that variable here, $IP? Yes, it's 10111. And that variable can now be used inside the body of the function. And as you can see, we're running just traditional ping.exe. We're passing in the contents of the IP variable, which we know is 10111. At this point in the game, when you're learning PowerShell, the best way to learn from this point forward is to start writing scripts and looking at other people's scripts, and to follow in your head the flow of execution when you're running somebody else's script. This is also how you troubleshoot. So this function is only 3 lines long, but that doesn't mean it's simple. There's a lot going on here. The param line, where we have a variable with a default argument, unless I overwrite that with my own argument. I'm then creating a function that I may or may not call. Down below, I am calling that function, and I'm passing in an argument to the script as a whole that goes into another variable, IP, which is used inside the body of the function. It's like follow the hot potato, right? Or follow the red bouncing ball as the argument goes from the command line into computer, into IP, and then finally into ping.exe. Again, I know for the more advanced programmers taking the course, this is obvious to you, this flow of execution. But for most people taking this course, this is not obvious at all. This is just flat out weird. But that is the next step in learning and understanding how PowerShell works. Like, this is important for understanding many programming languages. So from this point forward, the best way to learn PowerShell is by writing scripts and suffering your way through, and also looking at other people's scripts and following in your head the flow of execution. And now we see another reason why we have to know about the param keyword, because when you want to pass in arguments to parameters to scripts, not just to functions, but to scripts, well, your scripts, they must have the param line. That's not optional. When you're looking at other people's scripts on the internet, some of them will be short, some of them incomprehensibly long and complicated. But here's like an overall recipe or the overall layout of a typical script. In a typical script, you'll have the header. You'll have 0, 1, or many lines of comments describing the purpose of the script, command line arguments, legal restrictions, and so on. And you also have the param line. So as you can see in this case, we have a script with 3 parameters, x, y, and z. Now, in the middle of the script, and very often this is where you find like 80 or 90% of the lines of code in a script, are the functions. The functions can be defined inside the script itself, like function 1, 2, and 3, as you can see in the slide, or those functions could be in an external module, and then you would import the module here. Remember, you have to create a function or import that function before you can call it by name. So it's at the bottom of the script where the commands or functions are called by name. But now, it's that task, follow the red bouncing ball. Down here at the very bottom, I run getProcess, and notice that I'm piping the output of getProcess into function 2. So that means we jump up into the middle of the script, we execute the code for function 2, and then we come back to the bottom. Now what happens? Where does the output of function 2 go? It goes into a variable called output. Now we go to the next line. We have the if flow control keyword. If x matches this regular expression pattern, then execute the following block of code. Well, where did x come from? So you search inside the script and you say, oh, that's right, x is one of the parameters to the script. And then you might read the comments at the top of the script to remind yourself what that parameter is for. Now, if that regular expression does match the contents of the x variable, notice that we are calling function 3, which is here inside the script. It's not built into PowerShell. It's a custom function inside the script. And notice what we are passing in. We are passing into function 3 the output from the prior line. So notice that the prior line, the output of that command, was saved into the output array, and that array is now being passed in as an argument to the next function. Now we have another flow control keyword, while z is greater than 0. Well, what in the world is z? Oh, that's right, that was one of the parameters to the script. And while it's greater than 0, looks like we're calling function number 1, passing in the value of z as an argument. So in your script then, you would jump back up to function number 1, execute some code, but then notice when you're done running the function though, you come back down here, notice the semicolon. The semicolon is what separates commands that happen to be on one line. And what's the next command? What does $z minus minus do? What's that for? Ah, yes, it's for decrementing. So z might start out as a value of, let's say, 5, but then while z is greater than 0, but it decrements, it decreases by 1 every time I call that block of code. Now, once it's not greater than 0, then we continue on to the next line. So again, in this case, we're taking output. Where did that come from? That was a few lines above. We're piping that into where and doing a little bit of filtering. And then the output goes, hey, back into output again. So in other words, we're taking the current data inside the output array, filtering to exclude some stuff that we don't care about, and then updating that exact same array again. And then finally, whatever that data was, we're exporting it to a comma delimited file. So if we were to tell someone else, what is the output, or what does this function return? We'd say, well, the output is, it creates a CSV text file on the hard drive with the data that we want. Whew. It's exhausting. But on the other hand, when you're looking at other people's scripts on the internet, that's one of the best ways to learn. Take some interesting script that someone else has written, and then in your mind, follow the red bouncing ball, so to speak. Follow the flow of execution from one function to the next, and as you're piping data from one command to the next. This way you'll see by repetition over and over again the syntax and the patterns, and you might not be aware of this, but you're actually learning these patterns, you're internalizing them. It's like riding a bike. And over time then, these internalized patterns will become habits, so that when you're writing your own scripts, then it'll be a lot easier to start writing your scripts from scratch because, so to speak, you've seen these patterns over and over again. Following the flow of execution like this in your head is also how you troubleshoot. All right, so what we have here on the slide then is like a medium complexity script. You might find this from one of your coworkers or out on GitHub. You're afraid of running that script as is because you don't know what it does. So you have to be able to follow in your head. And as you're doing it, you're learning more PowerShell. This is not the only PowerShell material of this course. This is the fundamentals, the introduction. We're going to do more PowerShell over the next 5 manuals. Today's manual is the easiest manual of the week, and it's especially devoted to the people who are new to PowerShell. Now, for the other half of the people in the course, each day that goes by, the material gets more difficult, but also more interesting, more juicy. You can do more things. And if you're new to PowerShell, you might look at this and say, I really have no idea what's going on. That is okay. That is normal and expected. You're learning a whole new weird foreign language here. And the best way to learn any foreign language is lots and lots of repetition and examples. And that's what's going to come up over the next 5 days. So if you're feeling bad about yourself and you feel like, I'm the only one not really getting it, trust me, half the people in the course don't really get it at this point. And that is okay. That is normal. Please hold off feeling bad about yourself, so to speak, or feeling good about yourself. Please hold off until the end of day 6, because I think you're going to be surprised at how much you can learn in only 6 days. Because we have lots more examples to look at. We're going to do a lot more hands-on labs. Today's course, by the way, was basically one big lab. Hopefully you've been following along on your computer. But in the rest of the manuals, we have more traditional labs where you do it all by yourself instead of walking it through it all together like we have been today. That's it for today's manual. Have a wonderful night, and I'll see you tomorrow for the next manual.